most needed sensitive flow cytometry assay that you do in your laboratory. So when you're doing this assay, you have to be very careful with all the reagents you're using, the technical things what you're doing, the expertise of your technician matters much, because the value what you're going to give has a bigger impact on patient care. So we'll be seeing about stem cell enumeration, and I'll be telling you the basics, why we need to do cd34 enumeration, and how to do cd34 enumeration. I'll also show you a live analysis on how to get the absolute cd34 stem cell count by flow cytometry. Okay, so without wasting much time, let's go into the topic. So basic need for stem cell enumeration is for stem cell harvest, okay, and stem cell transplant. So what is stem cell transplant? To just share you, just to make it very short, we have a donor where this particular individual is normal. We collect the stem cells of this particular donor, okay, then we collect it by a procedure called apheresis or leukapheresis. So once we collect this leukapheresis sample, we process it. If the infusion has to be done in a later period, then we cryopreserve it. If infusion, or what I mean by infusion is administering this collected stem cell into the recipient is called infusion. So if you are infusing this particular stem cells which you have harvested from the donor immediately, then there is no need for cryopreservation. You can directly give it to the recipient. But in case you want to preserve this particular harvested stem cell so that the recipient is prepared before giving the infusion, then you will cryopreserve this particular harvested cd34 cells, and then when the patient is ready for infusion, then you infuse the particular stem cells into the recipient. The stem cells goes and engrafts, and then maybe normal hematopoietic stem cells starts produced from the infused or the donor stem cells in the recipient. Okay, if all goes good. Now this is called stem cell transplant in short. But now I made it very short, but there are certain things which we need to understand. So normally this stem cell harvest can be done, which I'll be discussing in the subsequent slides. Okay. Now, what is CD34 and what is its enumeration is? Now, CD34 is a glycoprotein which is found on the surface of stem cells and progenitor cells. Okay, so it is only seen in cells which are immature, that is progenitor, or we call the stem cells. And these cells which has the CD34 molecule has a pluripotent nature, or they have high plasticity so that they can differentiate into different hematopoietic cells, and they can start producing mature blood cells. Okay, so that is the stem cells, and CD34 is the glycoprotein present on those stem cells or the progenitor cells. Now, where do we look for these CD34 stem cells? So as we all know, they are present in the bone marrow. Okay, and they are also present in the cord blood. So now we see a lot of people coming and harvesting the cord blood for future use for the baby. Okay, so this cord blood has a rich CD34 percentage. So it has been preserved, and in case in future there is a need due to some hematological problem or something, then we can take those cord blood which has been cryopreserved and we can use it for the child. So that is cord blood. But you know what, like this CD34 stem cells are also there in circulation, but it is so rare to the percent so that we see it around 0.1%. That means like we see one cell among 1000 circulating leukocytes. One cell among 1000 circulating leukocytes may be a stem cell. Okay, so even these stem cells are seen in circulation. Okay, now, but that may not be sufficient enough when you want to harvest those stem cells or you want to collect those stem cells. For that, we do something called mobilization of the stem cells from the marrow to the peripheral blood and collect those stem cells in the peripheral blood via apheresis. Okay, so that process is called mobilizing the stem cells. I repeat, normally the stem cells which are there in circulation is at a percentage of 0.1. Okay, but that percentage may not be sufficient to harvest those stem cells in the peripheral blood. Okay, so we do something called mobilization. Okay, now when we do mobilization, some of the stem cells from the marrow will come into the peripheral blood, and the percentage of 0.1% in a normal situation or a normal scenario increases to 1 to 10% now. So once we mobilize, how do we mobilize? I'll let you know. So once mobilized, the peripheral blood stem cell count increases to 1 to 10% from 0.1%. So that particular process is called mobilization. Okay. Now, I'll tell you what is mobilization and how do we do mobilization in the subsequent slides. Now, why enumeration is needed? Why you want to enumerate the CD34 cells? So, as I said you in the first slide, once you harvest the stem cells from the donor by a process called apheresis or leukapheresis, you don't know how much is the concentration of stem cells in that particular product. You know what is leukapheresis? Leukapheresis is collecting the WBCs as such. Okay. Now this WBC has mononuclear cells, which is your lymphocytes, monocytes, so and so, has some neutrophils or granulocytes also, and along with it there are stem cells. But you're not sure how much of stem cells are there in that particular product or the apheresis material what you have got or you got from the donor. Okay, so you cannot blindly infuse that product to the recipient. Okay, you should know how much stem cells are there in that particular apheresis product before infusing it into the recipient. Okay, so you need to enumerate the stem cells in that apheresis product, and that is the first indication. Why you need to enumerate? Because without, say for example, now you got an apheresis product from the donor, and if that particular product has a very low CD34 count, okay, and if you are infusing that into the recipient, the stem cells may not go and engraft and start producing blood cells. So ultimately that will result in something called graft failure. So the patient will not engraft. Okay, so that is the indication why we need to check the CD34 count in the apheresis product before you are infusing into the recipient. Now, what is the ideal CD34 count which has to be there in the apheresis product before you infuse, so that it is optimal to infuse into the recipient? So the ideal dose is 4 to 5 million cells. 4 to 5 million, when I say cells, it is stem cells. Okay, 4 to 5 million CD34 positive cells per kg of the recipient. Okay, I repeat, the ideal dose, the ideal CD34 dose in the apheresis product should be 4 to 5 million CD34 cells per kg of the recipient. Okay, when it is meeting that dose, then engraftment is likely to happen. When you give a lower dose, say for example 1 million stem cells per kg of the recipient, there is a chance that there could be a graft failure because the dose is not adequate for optimal engraftment and production of blood cells. Okay, so this is very important. You should know this. Okay, so that is the first indication. Now the second indication is, I told you something called mobilization, right? So I'll just explain you what is mobilization now. So why you need to do mobilization? Because normally the CD34 cells or the stem cells in the peripheral blood in a normal setting will be very, very, very few. That is, it will be around 0.1%. Okay, but that may not be sufficient for us to harvest it by apheresis. So what we do, we mobilize some of the stem cells from the marrow into the peripheral blood, and this is called mobilization. I told you this. Now, how do we do this? Is we use, you all know what is GCSF, right? So this GCSF is given to the patient, 10 microgram for 4 consecutive days. So this GCSF is given every morning at a given time for 4 consecutive days. Okay. So once you have given it for 4 consecutive days, this GCSF will start releasing a lot of CD34 cells from the marrow into the peripheral blood. Now, on the 4th day after giving the GCSF, you for the CD34 count in the peripheral blood of the donor. Now, if the donor is having greater than 10 cells per, when I say cells, it means CD34 positive cells. Okay, when he's having greater than 10 CD34 positive cells per microliter, then he can be taken for apheresis the next day. That is the 5th day. In case the patient is showing or the patient is having lesser than 10 stem cells or CD34 cells per microliter, then we need to give him an additional drug. Okay, and that drug is called prelexifor. Okay, or sold under the trade name Mozobil. Okay, so now that drug is more intense and it will mobilize a more CD34 cells from CD34 positive stem cells from the marrow into the peripheral. Again, you need to check how much is the circulating CD34 positive cells in the donor. When it is then in that setting, when it goes beyond 10, then you can take him for apheresis the next day. So this is the second indication why you need to do a stem cell enumeration. So whenever you get a sample for CD34 enumeration, it should be either one of them. It should be if it's a peripheral blood sample, then they are checking whether the patient can be taken for apheresis tomorrow for harvesting the CD34 cells. Or when you are getting it in the apheresis product, when the sample is an apheresis product, ideally they are checking for the dose in the product. Okay. Am I clear? Any doubts? Are there any doubts? Am I making it very clear for you?
Clear, sir.
Clear, perfect. So these are the 2 settings when CD34 enumeration will be asked in the flow cytometry laboratory. Okay. Now, what is the principle of CD34 enumeration by flow cytometry? So what we do, a known volume of sample. Okay. For example, the common volume what is being used is 100 microliter. Okay. A known volume of sample, that is 100 microliter, is added to the fluorochrome labeled antibodies. Okay. So can anyone guess what are the antibodies we'll be using in this assay?
CD34 and 45.
Very good. So you definitely the aim of your experiment or the aim of your assay is to enumerate CD34 positive cells. So you should use CD34 antibodies. Correct. And now CD45, you may like that is one of the common leukocyte antigen. Okay. So you are using CD45. Okay. So you will be adding CD34 and CD45 to the known volume of sample, that is 100 microliter. Then you incubate it for some time so that these antibodies can go and bind to the target cells or CD34 cells. Okay, or like they go and they go bind to the respective antigens. Okay, give some time for incubation, that is 10 minutes. So the fluorochrome labeled antibodies, the reagent binds specifically to the cell surface antigens. Okay, then you are adding a 7-AAD. Okay, so I told you 7-AAD is the most commonly used viability assay when viability dye in flow cytometry lab. Okay, so now why we are adding 7-AAD? We are not adding it for leukemia lymphomas. Why we are adding 7-AAD to this particular assay? Any specific reason? Sir, we want to know.
We want viable cells.
Viable cells. Yes. So basically, as I told you in the introduction, this is one of the most sensitive as flow cytometry assays, because the count what you're going to give matters much to the clinician as well as the patient care. So leukemia and lymphoma is a qualitative assay, okay, and CD34 is a sensitive quantitative assay. So you need to add a viability dye to exclude all the non-viable cells, which is not going to do the job for us. So we want to exclude all the non-viable cells and only take the viable cells and enumerate CD34 in that viable cells. So final CD34 enumeration is not CD34 count. So the final line in your report should be viable CD34 cell count is equal to, okay. So only those viable cells will go and do its function in the recipient, right? The dead CD34 goes and it is waste of infusing that into the recipient, okay. So 780 dye is added to assess the viability, okay. Then we use NH4Cl based lysing solution, which is ammonium chloride based lysing solution is added to lyse RBCs. Now someone will tell me what is the processing protocol we use for this assay. We saw about 3 types of processing, right? In our 6th lecture, I suppose. Sample processing. So what are the 3 types of sample processing in flow cytometry?
So lyse stain wash, stain lyse wash, and lyse no wash.
Perfect. So here this is the 3rd type. Okay, so for CD34 and enumeration assays, you will do staining, lyse it, and no wash. You stain it, lyse it, no wash. Okay, so here we are using an ammonium chloride based lysing solution, which is basically lyses RBC by hypertonicity. Okay, so you lyse the RBCs, you will not wash it. Then what you do, since it's an enumeration assay and you want to do it by a single platform method, I'll tell you what is single platform, dual platform later. If you since it's an enumeration assay, you will be adding a beads of same volume. So if you're adding 100 microliter of sample, you will be adding same 100 microliter of beads to the tube, and then you feed it into the flow cytometer. Okay, this is spelling error. Okay, clear? So this is the principle of CD34 enumeration assay in flow cytometry. Okay, now what are the protocols? So how this CD34 enumeration slowly evolved. So it started way back in 1980, where Mill and Mulhouse, they formed a protocol where they used forward scatter with a side scatter gated events as denominator. So basically getting the absolute counts directly from the flow cytometer is called single platform method. I'll again explain you, but what is single platform is directly getting the absolute count, that is 300 cells per microliter or 700 cells per microliter. So if you're getting that absolute count directly from the flow cytometer, that is called single platform method. That is, you are using only one platform to get both the percentage as well as absolute count. Okay. What is dual platform method is, you will get only the percentage of CD34 from the flow cytometer, and you go back to your hematology analyzer for total leukocyte count, and then get the absolute count by calculation. That is called dual platform method. Okay, so for example, you are getting a CD34 percentage of say 5%. Okay, then you check the total leukocyte count in the cell counter. Okay, for example, some 5,000 cells. Okay, then with that you can able to get the absolute CD34 count. So this is called dual platform method because you are using 2 platforms here. One is a flow cytometer to get the flow CD34 percentage, and then you are using a cell counter to get the total leukocyte count, and with both of them you are deriving the absolute CD34 count. So that is called dual platform method. Okay, so if you are using a single platform, that is you are getting the absolute count directly from the flow cytometer, then you should not wash the sample. If you are using a double platform method, okay, then you can wash the sample because what we are interested is the CD34 percentage. Okay, so why I'm saying this, because initially it was a dual platform method because Mill and Mulhouse protocol, they got the percentage, and to derive that CD34 percentage, the denominator they used is forward scatter and side scatter gated events. Okay. Then then the modification came by Bender, who used CD45 as a denominator. Okay, this is basically for getting the percentage of CD34. Okay, both used isotype controls to set CD34 gate, which is not that right. Okay, so isotype controls. What is isotype control is? Say for example, if I'm using CD34, which is developed, you know what is host, right? You know what is host, what is target, and antibodies. I told you. So CD34, if I'm using an CD34PE, and this particular antibody is produced in host mouse, okay, and it is of IgG1 type. Okay, what is isotype control is? An isotype control is an antibody which has a similar fluorochrome. That is, if it is CD34PE, this is also antibody tagged to PE. It is also produced from the same host, that is mouse, and also this is of same IgG class. Okay, IgG1 means this is also IgG1. But this particular antibody will not have binding to any of the cells in the target. So if it is for human use and the target is human, this antibody will not bind to any of the cells of the human. So that is called isotype control. So it will be matching with your antibody what you are going to use. For example, in this case CD34, it will have the same fluorochrome, it will have the same host, it will also have the same IgG subclass. But the isotype control will not have a target in the, will not have a binding target in the humans. Okay. So that is called isotype control, and that is used to see a non-specific or a background staining. Okay. So that's called isotype control. Okay. Then there were some modifications later added by Nordic and the Sihon protocol. But now what we are using
the isotope control again.
Okay, so see what is an isotype control is isotype. For example, you tell me an antibody, just like that. For example, you are using a CD19 fcm8 antibody for your any leukemia, CRS, whatever. Okay, CD19 fcm8, and it has been so when you you bought it, and when you check that kit insert, that particular manufacturer would have given you. This is CD19. It is tagged to fcm8 fluorochrome, and it has been developed in host like mouse. Okay, so you want to know whether the CD19 is giving true signal or is it giving some background staining. Okay, now if you want to check that, what you can do is you can use something called isotype control. So I'll tell you what is isotype. Isotype control is a similar antibody. You should use a similar antibody. Okay. Now that has no specificity to any of the cells in humans. Okay. But it should have the same fluorochrome. When I say it is CD19, I said fcm8, right? So this isotype control also should be tagged to fcm8. If that is developed in a mouse, this also should have been developed in mouse. And if both of them should have the same IgG subclass. Okay, then you use that as a staining in your sample to check. See, I told you that isotype control does not have any binding to, it will not have any binding to the target species, cells of the target species. So you can use that as to check how much is background staining with isotype control, and then you can use your CD19 fcm8 in your experiment just to check how much is the background staining in your experiment. That is the purpose of isotype control. Now CD34, if you are using PE, you should use an isotype control for PE with the same host and same IgG subclass, just to check how much is the background staining. Okay, is that clear?
Yes, sir.
Perfect.
Why we need this single platform and dual platform?
Sorry, come again. Sorry.
Sir, single platform and dual platform that you are talking about, sir. Sir, why do we need to different instrument to again take the total count, sir?
I'll tell you. See, both as you say, for example, now if you want to do single platform method, you need to buy beads. I told you now, this one.
Yes, sir.
This beads you should buy. Okay, this is bit financially not very costly. I would suggest, like, if you want me to select one of the best is it single platform or dual platform? I would say single platform is the best method. Okay. Some people initially when they were developing this, beads was not in use. So what they did is they used flow cytometry to check the CD34 percentage in the among the WBCs. Then they get the total count from the counter and then they calculated absolute CD34. Okay, but now most of the area, most of the places, they're using only single protocol. Or nobody is using dual platform for CD34 especially. They're all using single platform method.
Yes,
okay,
sir.
So you just fix it now. Single platform is the method. I am telling you the other way. Okay, clear?
Sir.
Yeah. So now I want you to remember the name. Okay. ISH protocol. Okay, which is International Society of Hematotherapy and Graft Engineering. Okay. So this is where a big breakthrough happened in CD34 enumeration. So till date, we are using this particular protocol for CD34 enumeration. Okay, which is called ISH, which stands for International Society of Hematotherapy and Graft Engineering. Okay, so they gave, and it was given by Robert Sutherland and Michael Keeney. So they gave a protocol for enumerating the stem cells, which is still being used. Okay, so they used CD34 and CD45 staining together. So initially these people, when they were doing, they were using only CD34 antibody. And they were taking denominator as forward scatter, side scatter, and so on. But here CD34 and 45 staying together with a sequential gating strategy. They gave a beautiful gating strategy that is stepwise how to enumerate your stem cells or gate the stem cells. So the advantage of this method is it reduces interference by debris, dead cells and other cells which non-specifically bind to antibodies. And they also brought in the viability die. Okay, so if someone asks you what is the protocol you're using for CD34 enumeration, you should say this name, ISH. Okay. Then the same authors or the same people, they developed a single platform where they introduced beads. Okay, so now the single platform method, you need not go to the cell counters at all. By adding the beads, you can get the absolute counts in the flow cytometer itself. So these beads are nothing but they are something like calibration factors. So when you're adding 100 microliter of sample, you will be adding 100 microliter of beads. Now these beads come with a known concentration. That means the manufacturer will tell you that these beads, what they're giving you, has 1000 beads in 1 microliter. So you are adding 100 microliter of beads. So totally how many beads are going into the sample? 1000 into 100, correct? So it's around 1 lakh beads are in the sample. Now when you acquire in the flow cytometer, you get the number, I'll show you during the analysis. So with that known concentration of beads, you will be calculating how much is the absolute CD34. Okay, that is a concept of single platform method. Okay. Now, so the highlights of the currently used ISH protocol is, it's very simple. So you stain, lyse and no wash. Antibodies you use is CD45 FITC and CD34 antibody, and this CD34 antibody should be pan CD34 PE, and it should be of class 3. Okay, so I'll tell you what is class 3. Then you do a sequential gating to quantify the true CD34 cells. It's a single platform method and it has a viability die incorporated. So you are very sure of the values what you are finally signing out. Okay, so if you take CD34, there are many commercial kits available. So you should not think like I can buy CD34 from this particular vendor, I can buy CD45 from that particular vendor, and beads from this particular vendor. So you can't do that. When you're coming to a protocol, it should be more harmonized. So a single kit, it comes as a single kit where it has the antibodies, it has the lysine solution, it has the beads, everything in one pack. Okay, so that is called a kit. So many kits are there. There is STEM kit, which is from Beckman Coulter, and there is something called True Count, which is from BD Biosciences, and there is something called CD34 count kit from DAC. Okay, so you can just check this on web. So this is STEM kit from reagent. So you have the lysine solution coming with it. This is ammonium chloride. Then you have the antibody. You also have the viability dye, and you also have the beads. Okay. The characteristic feature of these beads is that these beads are designed in such a way that they will give you bright signal in all the channels. Normally, if you take an antibody fluorochrome complex, the antibody will give signal. The antibody will give signal to the channel respective of its fluorochrome conjugated. Correct. So if I'm using cd45 fitc, cd45 fitc signal will be there in only channel 1, that is fitc channel. But these beads will be designed in such a way that they will be giving fluorescent signals in all the channels. All the channels in your instrument. So if you're using 10 colors, it will be giving signal in all the 10 channels. So it is designed in such a way, and even that signal will be very bright so that it will not interfere with your experimental signals or antibody signals. Okay, I'll show you that. Okay, now this is stem cell enumeration kit of BD Biosciences, where they also have an lysine solution. They have the viability dye. They have the antibodies. They have the tube, which has the pellet already in it. Here you need to drop the beads to the tube. Here the beads are already there in the tube. Okay, now I said you right, during cd34 antibodies, it should be banned cd34 antibodies and it should be class 3. What is this class 3? So cd34 antibodies are of 3 types. One is class 1, class 2 and class 3. Now class 1 and class 2 has some disadvantages. That's why we are residing to class 3. So class 1, these antibodies are sensitive to neuraminidase and O-siloglycoprotease. Okay, so they can be damaged or there can be a problem in binding. And similarly, as I said you, they fail to detect all glycoforms of CD34. So this class 1 binds to only some forms of glycoforms of CD34. It may not bind to all the CD34 glycoforms. That is second point. And third, these antibodies, when conjugated with negatively charged fluorochromes like fitc. Okay, fitc is a negatively charged fluorochrome. So when these antibodies are tagged to negatively charged fluorochromes like fitc, they lose their binding capacity because this O-siloglycoprotease is negatively charged. And even when your fluorochrome is negatively charged, they may have an inefficient binding because of a repelling effect. Similarly, if you take class 2, the class 2 is not sensitive to neuraminidase, but it is again sensitive to O-siloglycoprotease. And this can detect all glycoforms of CD34 compared to class 1. But again, the third problem is similar to class 1 because again, since O-siloglycoprotease is there, they have problem when you are using a CD34 conjugated to fitc or a negatively charged fluorochrome like fitc. Okay. Hence, we finally came up with this class 3 CD34 antibodies, which is insensitive to both the enzymes we saw, that is neuraminidase and O-siloglycoprotease. It detects all glycoforms of CD34 and any antibodies bind regardless of fluorochrome conjugation, because since it is insensitive to O-siloglycoprotease, these antibodies can bind regardless of any fluorochrome conjugation. Okay, so you can even use, when it is a class 3 CD34, you can still use it with fitc, no problem. Okay, so that is about, so the point which I want you to remember is, we are using a pan CD34 class 3 antibodies for stem cell enumeration. Okay,
this is just for stem cell enumeration or for all the assays we are doing in flow cytometry?
Stem cell enumeration, stem cell enumeration is a special test. It's a highly sensitive test. So we are very careful in each and everything. We are using a viability dye for the same purpose, and we are also selecting a very particular type of antibody because it's a very sensitive test. For leukemia lymphoma, we may not be using a class 3, even you can use any class, but for stem cell enumeration, you should be using class 3.
So only this needs to be taken care of while doing stem cell enumeration.
Perfect, yes. But if you're buying a kit, they will take care of it.
Okay, sir.
Okay, so I told you now if you're doing stem cell,
so we cannot buy CD34 alone. So it will come in the kit and that will be class 3 only.
Exactly. I don't recommend you buying CD34 alone. Okay. Buy as a kit, that is better because it's more stable. You can't, as I said, you can't buy cd34 from one vendor, lysine from another vendor, 45 from another vendor. So that is not harmonized. Now, so you better you buy it as a kit, and that's how people do it. Okay,
sir.
so that is about. Now let's see the procedure, and then we can go for live analysis. Okay, so always process in duplicates. The explanation is again, it's a sensitive assay. So if you are pipetting, you are doing it manually, right? So when you do it in duplicates, for let it be if you are doing in only one tube. Okay, for example, by mistake there could be a pipetting error in that one tube, and if you are still processing with that and getting the count from that tube for 100 microliters, if you are just adding only 90 microliters by error, your pipette because of your pipetting error, then the count which you're gonna get is low. So what has been proposed is you always process a sample in duplicates. That is, you take two tubes, pipette 100 microliter in tube 1 and again pipette 100 microliter in tube 2. So maybe if you have missed in the first tube 90 microliter and the second tube will be 100. So when you are finishing analysis, you will get two values. Okay, and you can take an average. So that can cover up a bit. Okay, so that is the reason why we do it in duplicates. Okay, now adjust the WBC count of the sample to 15,000 to 30,000 cells per microliter. This will not be a problem when you are doing the cd34 enumeration in peripheral blood during the day 4 in the donor. So, yes. Okay, but when it is a product from the apheresis product which has been collected and sent to your lab, it's a leukapheresis sample. So, it will be completely packed with WBCs. There the count will be very high. So what you need to do, you need to dilute the sample to an extent that your WBC count is around 15,000 to 30,000 cells per microliter. Clear? Then you add CD45 FITC and PE to all the tubes. Okay, so whenever you are doing CD34, you will also be doing an unstained. That is, you will not add CD34 in one of the tubes. So you will take 3 tubes. 2 tubes are duplicates, as I said you, and 1 tube will be without CD34, just to check is everything fine. Okay, just it acts as a unstained tube. Okay, so now after adding CD45 FITC and 34 PE, then you add 100 microliter of sample to the test tube. Okay, what is reverse pipetting? What is reverse pipetting? Anyone? Reverse pipetting.
Sir, it pipettes more sample and
No, you tell me what is reverse pipetting.
Required amount.
No, you tell me what is reverse pipetting. Or have you? I mean, you would have used a pipette, right? During your post graduation or now or something, you would have used a pipette. What is reverse pipetting? Tomorrow, what you do? You go take a pipette from your lab. Okay. If you press the pipette, first will be a soft press. And if you give more pressure, it will still go in. That is called a hard press. So first press will be a soft press. Then if you give more pressure on the thumb, it will again go in. That is called second press. Okay. Now what is reverse pipetting is when you are taking the sample from the vacutainer or from the sample tube. When you are taking the sample, you should take with soft press and hard press. So double press. Once it has been aspirated into the pipette tip, take it out, gently wipe off the sample in the tip, outside the tip with a tissue paper. And when you're dropping into the tube which is with antibodies, you drop by giving only a soft press, not the hard press. This is called reverse pipetting. Okay, so when you're taking the sample when you're drawing the sample, 2 press, and when you're releasing the sample, single press. That is called reverse pipetting. So you know what is forward pipetting now.
So why
forward pipetting? Sorry,
the advantage of doing this, sir?
Dispenses correct volume of sample. It dispenses correct volume of sample. If it is 100 microliter, it dispenses correctly 100 microliter. Now forward pipetting is when you're drawing the sample, it will be a single press, soft press. And when you're dispensing the sample, it will be double cross. That is called forward pipetting, which may not be that great. Okay, so you should do something called reverse pipetting. Understood?
Sir.
Yes. Now then you add 220 microliter of 780, which is your viability, 20 microliter. Okay. Now you leave it for 20 minutes. So that's these antibodies and dyes goes and bind to the cells. After 20 minutes, okay, you had 2 ml of lysine solution, which is ammonium chloride based lysine solution. Again, incubate for 10 minutes so that the ammonium chloride lyses the RBCs in this 10 minutes. No wash. You should not wash it. Okay. Then finally you add enumeration beads 100 microliter. So I told you, right? Same. The beads should be of same volume of sample. So you are adding 100 microliter of beads to the tubes. Then you go to the flow cytometer and acquire in the machine. Okay. So when you are acquiring, how much events you should acquire? You should acquire 75,000 of CD45 positive events, or you should acquire a minimum of 100 CD34 positive cells. Okay, for example, if the sample is leukopenic and you are not able to acquire 75,000, at least this has to be satisfied, 100 CD34 positive cells. It is better you satisfy both. Okay, so until then you should acquire the sample. Any doubts? Clear?
Yes.
Got the procedure? Great. So, analysis. So I told you about analysis. So you should start with universal start points, which is your time plot to ensure that there is a stable acquisition. Then you see the since you are using a viability dye here, your forward scatter, side scatter can be ignored. If you want to add, you can add. Then you should exclude the doublets by forward scatter height and forward scatter area plot. Then side scatter CD45, and then I'll tell you what to do. Okay. So this is the step. Select only the viable cells. After this universal plots, you select only the viable cells with side scatter 7AAD plot. So which is viable? 7AAD positive is viable or 7AAD negative is viable? Negative.
Negative.
Yes, negative is viable because 7AAD is a DNA binding dye and it cannot permeate into the cell when the membrane is intact. The membrane will be intact in a live cell. So in live cell, this 7AAD cannot go inside and bind to the DNA. Okay, so it will fall, all the live cells will fall in the negative area. Whereas if it's a dying cell or when it's a dying cell, there will be holes or pores on the cell membrane. So this dye can go inside the cell and bind to the DNA and give you the signal in dead cells. Okay, so 7AAD is a viability dye, and all the 7AAD negative population is live cells, and the population which is positive for 7AAD are dead cells, so you will ignore them. Select only CD45 positive cells. After selecting the viable cells, then you select only the CD45 positive events. So you will ignore all the CD45 negative events. Okay. Then as you do that, you also gate the lymphocytes, which falls in the CD45 bright area. Okay. Then select the CD34 positive events with side scatter versus CD34 plot. Okay, see, you need to memorize this, and when I'm doing, you should say one by one. I will not, during analysis, I'll ask you every step. Okay, then exclude cells with high side scatter and select only CD45 dim population. So once you finish that CD34 gating with side scatter CD34, you gate those CD34 positive cells in side scatter CD45 and then select the cells which are showing dim CD45. Stem cells are precursors or progenitor cells, right? It cannot show bright CD45. One dictum in hematology or in immunophenotyping or even in anything, like as the cell mature, it acquires CD45. When the cells are immature, the CD45 is relatively less. So stem cell being a progenitor cell, it will show a dim CD45. Lymphocytes, since it's a most mature cells, like they are mature cells, they'll show bright CD45. Okay. So now you select only CD45 dim population. Then you exclude the cells which is showing high forward scatter and side scatter. Again, this population is still refined. So you are refining that CD34 cells to the maximum so that you get only the true CD34 positive cells. Okay. Then you exclude cells with high forward scatter and side scatter using lymphocytes as reference. I'll show you this. Okay. Then identify the bead population. Okay, and refine it with time versus FSC. The last 2 points you may not be very clear. Don't worry, when I'm showing an analysis, you'll understand. Okay. Then you need to identify the beats, refine the beats, and check this. Okay. Then finally, with this particular formula, you can count the absolute count of CD34. So CD34 events into beats concentration. If you have diluted the sample as we do it in product, because product the count will be very high, so you will dilute it. So if you are diluted, you have to correct it to the dilution factor divided by beat events into volume. So this is how you do. Okay. Okay. So total CD34 into beats into dilution factor by beats into sample volume. This one again you just note down. Okay. If you are using an automated software, the software can do this auto calculation for you and give the values. But if you want to calculate manually, you can still do that. Okay. Shall we go for analysis? Shall we go for analysis? Any doubts now?
No, sir. Yes, sir.
Yes. Yes, we can go, right? Perfect. If you have any doubts, ask me anytime. I'm happy to take. Right. Now let's go for the analysis. So now I'll stop. Should I stop my sharing? Is my Kalusa visible?
No, sir.
It's not visible, right? Okay.
No, sir.
Now I'll stop the sharing. Now is it? Now it's
Yes, sir.
visible.
Yes, sir. Visible, sir.
Perfect. I'm going to delete all the plots because this is unstained. So second will be stained, I suppose. Now you need to tell me how to do this. Okay. So first plot I'll draw. The first plot is time plot. Time plot. So you put time and forward scatter. So you find that there is some stable acquisition. Okay. Okay, there is stable acquisition. Second plot. Second plot.
Viability.
No, before that singlets.
Singlets. Okay.
Correct? Okay. Okay. Now this doesn't have peak. There is no peak here, so that has been disabled. So you should do that. Okay. So there is a problem here. So forward scatter area is there, but I need peak. But that has been disabled. Let me check here. If it has been disabled, or yeah, it has been disabled. Let me talk to the people tomorrow. Okay. The second plot is the singlet plot. You know, right? You need to do it with forward scatter area or integral versus forward scatter peak or height. Okay, so you get the singlets. Now, since it's not there, let's ignore. Then now we have to go for viability. Okay. Okay, now I need to draw a gate on only the viable cells. So these are the dead cells which are showing which are showing 7AAD. Now I'll gate only the viable cells. Okay. So what happens is some of the labs, they will have a locked protocol. That means what I mean to say is already these protocols would have been created and the technician just runs the sample in that particular protocol and you'll get the value and it directly gives the value. If it is being happening in your lab, always have a check on it because you don't know what is happening. When this gate has been changed like this, then the count goes low. So when it is a locked protocol or even the protocol is already established and it's going without any supervision by your technician, then you should have a look whether the gates are all perfect and the things are all fine. Because what I mean to say is when this goes wrong, then things will be very bad. So you should always have a check on it. Okay, now the next particular plot? What is the next particular plot?
So viability. No,
Viability we have done,
CD45.
huh?
So
Now we have to go for CD45.
CD45. Yes, sir.
Perfect, perfect. Side scatter versus CD45. 45 fixing. Okay. Now I'll drop the viable cells here. Okay. Now I've got the viable cells. Now I don't want these cells which are CD45 negative. So I'm going to remove that. Okay. So I'll select only the viable cells. Okay. Done. Next plot.
Sir, why to remove dim CD45 cells?
Why to
Remove these cells.
This
CD45 dims.
CD45 negative or dim?
Negative or dim cells. Why to remove?
You need to remove that, right? Because see, that could have some amount of debris and all these populations. So it can show some non-specific or false positive CD34. See, the problem with debris is, see, for example, it could be a fragmented cell. Okay, or it could be some other non-specific other debris. So now this, what happens? They will give you a false positive CD34 signal. Okay, that is the reason why we are eliminating them. Now you tell me what is the reason why we are removing this, because this particular cells which are here CD45 could be anything. It could be a platelet. It could be an RBC fragment. Getting my point? And they can show a non-specific CD34 positivity.
So means we will select only the bright cells. Dim to moderate, all those we will ignore.
With respect to CD45, you say?
CD45, yes, sir.
Yeah, see, CD45, see, this is bright. I'm including till this.
Okay, sir.
If you want, you can include till. See, if you're not happy, sir, no, sir, that is moderate area, sir, you still include, okay, I'll include this. But definitely not the negative.
Sir, understood.
Okay. So once this is done, now we'll go for the next plot. The next plot is
CD34.
perfect. Perfect. So CD34. Okay. Okay. Now there is a compensation problem. So I'll check the compensation here. How do you check for compensation? See, whenever you are checking for a compensation, what you do, you check for all the possible combinations. Okay. So if now there is some compensation, you just check with all other markers you are using. See, this is the compensation problem here. Okay. Done. Right. Now this is done. So you're taken only CD45 positive cells, then you're getting your CD34 positive cells. Okay, now you gated the CD34 cells, but you need to still refine it. Okay. Okay. Now for refining, what I'm going to do first, let me check whether this this CD34 which I've gated is really falling in CD45 dim region. Sorry, I've made as a composite, so the first file is coming. Yes. So you find that in my CD34 there are some events which are CD45 bright. So as I told you, CD34 is a stem cell. It's a progenitor cell. It cannot show trait 45. So these are all some non-specific CD34 binding. Okay, if you want, I can show that where it's part of my CD34 gate. See, so it's part of some non-specific events which is coming into showing non-specific CD34 positivity. See the scatter here. Similarly, you see here the viability. It's almost some dead cells because it's showing some dim CD7A80 positivity. Okay, so now I'm not going to be interested about that. So I'm going to limit. So I need to refine my CD34 positive cell. So I'll refine it like this. Okay, so first refinement is with side scatter CD45. Okay, we missed a step. So when you're doing this, when you're using side scatter CD45 to gate only the CD45 positive events, you should also gate lymphocytes simultaneously. That particular step we missed. Okay, I'll tell you why. Okay, so this is done. Now what I'm going to do is I need to refine the CD34 further. Okay, first I have refined it with CD45. So I have excluded all the CD45 bright and CD45 negative populations or something, because CD45 negative we have almost eliminated here, so that is not. So I've eliminated some non-specific CD34 positive events which are CD45 bright. So this can't be stem cells, so I've removed it. So I've just gated only CD34 positive cells which are falling in the CD45 dim region. Now second way of doing is with scatter, side scatter and forward scatter. Because you know forward scatter gives you the size of the cell and side scatter gives you about the granularity of the cell. You know stem cells are agranular, right? So it does not show much scatter. So, and the population which you use as a control here is lymphocytes. So that is why we need to gate the lymphocytes during our side scatter CD45 plot. Where is the lymphocyte? Lymphocyte is D. Okay, so I'm using D. I'm just flipping it. Now what I'm doing, I'm just drawing a control region with lymphocytes. Okay. Why I'm doing this? Because I'm using lymphocytes as a reference population for size and scatter. Okay, now what I'm going to do, I'm just going to copy this particular plot and drop it. And then what I'm going to do, I'm going to gate this CD45, CD34 positive population refined with CD45 here. That is C. Okay. If you see here, there are some dots which are falling away. You can see one particular population falling away. So we can still refine them. Okay. Even we can take that. Okay. Now this is the final CD34 positive population. Okay. So how much is the population? We can just check the number. Okay. So it is around 876. See, remember, this is not absolute count. This is the number of events. Okay. Now absolute count we need to calculate. Now, if it is like which we should not do this for CD34, but I'll tell you how it was done previously before these guidelines came in. So what they do, they check the percentage of CD34. So I'll tell you percentage of CD34 among the CD45 positive events. Okay. Now, how that is done? So now CD45 positive event number is 74,958. Okay, somebody if they have a calculator, please tell me. 74,958. In 74,958 events, CD34 is 869. So what is the percentage? Can anyone help me, or anyone has a calculator? So it should be 86900 or 869 into 100
1.15.
Perfect. Super. So 1.15 is the CD34 percentage. Now what people do if they have it, if they want to do it by double platform, or what was previously done is they run this particular sample in the cell counter, and the cell counter gives you a total count, for example 10,000. Now what would be the absolute count? So 10,000 cells. So if you convert the percentage to absolute count with the total count, what you got in the cell counter, you get the absolute count of CD34. Okay. So it will be like, so if it's 10,000, it should be 1.15, you said, right? So it will be like 115. 115 is the absolute count. Okay. So that is how absolute counts are calculated in dual platform method. But now for CD34, you can do this for lymphocyte subset analysis. For calculating absolute count of lymphocyte subsets, you can use this method, dual platform method. But for CD34, now the guidelines has come, you can't do this. Okay, you need to do it by single platform method. Okay, now how to do that? Now we have finalized the CD34 positive population. Now we need to track the beats. Where are the beats? Okay, so as I said, beats will show high fluorescence with maximum intensity. So it will be somewhere hitting the ceiling. It will be so bright. So let's check where are the beats now. You can see this population. I'll enlarge it to it. Can you see this population here? That is not a line, that is a population. That is, those are the beats. The beats are so bright that they fall with maximum intensity. Okay, now what you need to do, you need to draw a region around that particular population. I'll show you. Okay. Okay. Now these beads has to be a bit refined. Okay. Refining is done with, I prefer forward, you can refine it by many ways, but I prefer forward scatter versus time. Okay. Now this is the beats. Okay, so there are some beats which are rough, so I'm not going to take that. So I'll refine the beats. So we refine CD34, right? So similarly, we'll refine the beats, and these are the final beats. Sorry. Okay. Now you need to calculate the number of this. So I told you a formula, right? So you can calculate the absolute count with that formula, or if you're using a software, I'll tell you how automatically the software will give you the CD34 absolute count. Now you can go to option called protocol options. There you have used beats, right? And the final beats is final beats. So you select final beats. So that is the beat gate name is final beats. So I select final beats, and it will ask you what is the cal factor, that is what is the concentration of beats in per microliter. Okay, so I'll just put 1000. That means 1000 beats in 1 microliter. Okay, then I'll enter. So once if I've entered this, now I can get the CD34 absolute counts directly. Now this is the final refined, this is the final refined CD34, right? So it's confusing. Okay, now this is the final CD34. So you just click and check for cells per microliter. So that is 121 cells. 121 is cells per microliter. See, this is not absolute count. That is the number of events. Now this is the absolute count. Okay, so this is how you do. So this is the final stem cell count, absolute count. So the final report should say the viable CD34 positive events in the given sample is equal to 121 cells per microliter. This is a peripheral blood sample. Okay, so there is no dilution. In case you get a product, you use the same protocol, same method, but there you need to correct with the dilution. Say for example, if you have diluted the product, the apheresis product in 1:5 ratio, okay, with PPS or something, then you need to multiply it with 5. Okay, so that is how you do it. Any doubts? Any doubts?
No, sir.
Perfect. So your masters of CD34 enumeration. If your lab is doing, tomorrow go take charge. You check everything. Okay. So this is what. So what happens is that if the lab doesn't have a good pathologist or people who are not very good flow cytometry, they will sell the machine, and what they do, they create something called this protocol. What I have done one by one as together is called protocol. So they make this protocol and they will lock it. Lock it means that you cannot adjust this like this. Okay, they will lock it. And whenever you get a stem cell, CD34 sample, your technician who doesn't know anything just drags the protocol, acquires in that particular protocol, and finally the value will come here and he will give that off. But that is not right all the time, because you need to check whether the gates are all correct. You need to check whether the CD34, which is the final count, is really from the desired areas. Now see, I'll just give, you need to check. See, now the CD34 is correctly in the correct location. So what I have done is right. For example, if this particular CD34 is falling somewhere in the margin of this particular gate, or if it is falling somewhere in this particular area, then that is wrong. You need to check it. Okay, it should be done under supervision. Though it is a locked protocol, you need to check, because a debris sometimes can give you a lot of nuisance. It can give a false elevated CD34 count. So you need to be very careful. Okay. So if your lab is doing CD34, ask them what protocol they are doing. Is it locked or open protocol? And how are they doing it sequentially like this? Or it's already there. Nothing wrong if it's already set. Before signing it out, check it once that everything is perfect. Okay, that is my suggestion. No other doubts? Clear?
Yes, sir.
Perfect. So thank you. Yeah, sorry.
Sir, please explain this forward versus side scatter, that final CD34 count.
This one, nah?
See, next
what?
one.
Yeah, see, basically what I'm doing is I'm using, once I've refined with 45, that is, I've selected only CD34 positive events which are showing CD45 dim intensity. Okay. After that, still I want to refine it with scatter. Okay. So here I'm using lymphocyte as a control. So getting the lymphocytes in forward scatter, side scatter, I'm just gating a region around it. So I cannot find a stem cell or a CD34 cell which is smaller in size than lymphocytes, correct? So I've drawn a region around it, and then I've copied it, pasted, I've just copied that particular plot, and then I've gated the refined CD34 again here. So by that I can eliminate some CD34 positive events which are having a high forward scatter or a high side scatter. So this is again still more refining it, that's it. And I'm using lymphocyte as a control to refine it with scatter. As simple as that. Okay. Clear, or should I repeat it? Clear, huh?
Yes.
Great. So we are finishing CD34. So the remaining classes is PNH we'll be discussing. Then we'll discuss on lymphocyte subset analysis, immune deficiency. Then the final class will be on quality control. So we have 3 more lectures remaining. And next week will be assessment. So I'll post the link for the assessment possibly on Monday or Sunday. You can do it and finish it. And next Friday, we'll again discuss on PNH, detection by flow cytometry. Thank you. Good night.
Thank you, sir.